going to take a look at section 3.3, which is on trig identities. Basic idea behind trig identities is, I'll show you an example of one. I give you something like that, and we try to make it as simple as possible.
That's pretty simple.
Yeah, we can make it a little simpler. I'll show you.
Do we kind of like English?
We need to. So, I'm not going to worry about
We're doing
that.
part 1 and part 2 today or no?
Today is just part 1.
Oh, okay.
Alright, so let's start with this. So in trig, there's 3 different categories of identities we're going to look at, and a lot of them we already know. Okay, this first group we've already done. When we use the graphing calculator, and we want to type in a trig function, which buttons do we have trig functions for on the calculator?
Cosine, sine, tangent.
Tangent. So those are the first 3. What are the 3 we don't have buttons for?
Cosine.
Inverse, cosine.
No.
Secant or cosecant.
Secant, cosecant, and cotangent. Okay, we don't have buttons for those.
Yeah,
So if we want to type in secant, what did we learn about how you type in secant?
-1. Or the power of -1.
That's inverse. So you're not going to need the power of -1 thing today.
I don't remember ever
Second.
talking about
Don't you do 1 divided by?
1 divided by, right? You flip it. So if you want to type in cosecant, you have to take the sign and flip it. Take the sign, flip it, and you get the cosecant. What if you want to type in secant? We don't have a button for it, so
that.
we
You
have
do
to
the same thing
with what?
with the over 1. Over cosine?
Over cosine.
Yeah.
If you take the cosine and flip it, that's how you get secant. And what about the cotangent?
You do it with tangent underneath it.
Yep, so you're going to flip the tangent. Now, we can write, this is kind of the same thing, but if you take the cosecant and flip it, that would be the sine. Okay, so if you flip sine, you get cosecant. If you flip cosecant, then you get sine back. What if you flip the secant?
You get secant, cosine.
You get cosine. Yeah, it's really the same. It's saying the same thing. And what if you flip the cotangent?
You get tangent.
Yep, you get tangent. Now, these are all called identities. Identities mean that you can plug in any number for that angle, and it will always work. So if you wanted to find the cotangent of 34 degrees, you could do 1 over tangent 34. It works for 34. If you want to do 76, you can do it with 76. It's an identity. You can do it for any number you want. We're not really going to be doing it with numbers. We just need to know those formulas. Mainly the first 3 on the left. The 3 on the right are repeats. All right. And the next one. So the next one is called a quotient identity. If you take sine and divide by cosine, that is tangent. And the point isn't really to show you with a number, but I'll show you. Let's pick an angle.
28.
28. If I take the sine of 28 and divide by the cosine of 28, I get that. And if I take the tangent of 28, the tangent is exactly the same thing. So sine divided by cosine will always give you tangent. So the point for this formula is if you ever see sine divided by cosine, you can write that shorter. You could just say tangent. So the whole goal is to write things as short as we can. How about cotangent? What do you think that one would be?
Sine over cosine.
So that's tangent, sine over cosine.
Would it be tangent over sine? Or sine over tangent?
What's the connection between tangent and cotangent? Like if you know the tangent, how do you turn it into cotangent?
They're inverse, so it's going to be cosecant over secant, right?
Sine over tan.
So
Secant over.
how do you get cotangent? What did we say earlier?
1 over tan.
So you take the tangent and flip it, right? That's the connection between the two. cotangent and tangent are just flipped versions of each other.
Yes.
So
Cotangent and tangent.
what do you think cotangent would be here, based off knowing that one up there?
Cosine over sine.
Cosine over sine. It's just the flipped version. So for today, those are the only ones that we need.
Why?
Because I'm not going to do the other, I'm going to give you the other group, but I'm not going to give them to you
Can
as
you go back
problems.
down a little bit so I can copy the bottom?
Because if I do all three groups in the same day, it gets confusing.
Oh, it's already.
So we're going to do the reciprocal and the quotient.
Are there questions of the other ones?
No, not
Oh.
ones that we use.
Oh, I get it now.
That's the only two.
I understand.
All right. So let's try an example. So that's all we need for formulas. I don't think I'm going to mention that right now.
Don't mention that.
Okay, so let's do this one. So I want to simplify secant times cosine. So one trick that you can use when you are trying to simplify one of these is to change everything in the problem that's not sine or cosine into sine or cosine. Okay. So if we read that, the second thing is a cosine. What's the first thing?
Secant.
Okay, is that sine or cosine?
Cosine.
I mean, does it say sine or cosine for the first one?
Yes.
No,
No, what does it say?
But
It
it's
says,
not-
it
oh.
says secant.
I thought you were talking about trig functions in general.
So what we want to try to do is change anything that doesn't say sin or cos into sin or cos. So we're going to focus on that.
Why is that? Why not sine? Or why not tangent?
Why not tangent?
Yeah.
Just because it doesn't make the process work well, generally. Yeah, we're going to try to change it into sine or cosine. So let's start with secant. What is secant?
1 over cosine.
That is 1 over cosine. Yep. Any question why secant turns into 1 over cosine? That's from the formulas I just gave you.
Cosine is.
Yeah, now how can you write cosine? Let's do it.
Secant.
Let's do it as a fraction. And this is how you can make anything into a fraction. We're not gonna do much to it.
Put 1 on top of it.
Put 1
On the bottom of it.
on the bottom.
Cosine over sine.
So now you've got 1 over cosine times cosine over 1. When you multiply two fractions, let's pretend like you had numbers. 1/3 times 3 over 1. That's basically the kind of thing you have right there. You go straight across. Right? But if you have the same number in the top and the bottom of a fraction and you're multiplying, what happens?
It equals 1. 3. It equals 3.
So what happens when you have the same number in the top and the bottom of a fraction?
They cancel.
They reduce. Yeah, you can reduce it. What number goes into both 3 and 3? Yeah. 3 goes into itself how many times?
Once.
Once. And how
One.
many? Once. So you're left with 1 times 1 in the top, 1 times 1 in the bottom. So now let's do the same thing here. Do we have something that's in the top and the bottom of both
Yes.
fractions? Yep. What is it?
Cosine.
Cosine. We have how many cosines in the bottom?
1.
1 there. How many in the top?
1.
1 there. They're going to cancel out, just like those canceled out. And now multiply what's left in the top. What do you have left in the top?
1.
1. And what's left in the bottom?
1.
1. And that's just 1. So in that particular problem, if you take the secant and you multiply by the cosine, you always get the number 1. Doesn't matter what you fill in for an angle right there. Like if you did the secant of 42 times the cosine of 42, it would be 1. Secant of 12 times cosine of 12, 1. How about secant of 9 times the cosine of 9? 1. It always comes out to 1. Anytime you do secant times cosine. Well, that's it. That's one type of problem. Any question on that first one?
I have a general question.
Mm-hmm.
I still don't really know what taking a cosine is. Like, what is the function that's being done?
Cosine, if you think of it in terms of a triangle.
Or like any trig function, any of them.
So a trig function is when you take the length of one side of a triangle and you divide it by the length of another side in a triangle. Cosine is specifically the adjacent length over the hypotenuse length.
Okay, so you say cosine like 25. What's the 25?
The 25, that would be, like if you drew a triangle,
Yeah.
that would be right there. So to find the cosine of that, you measure how long that is, you measure how long that is, and then you
Well,
divide the
like when you
two.
put it into your calculator, cosine 25, it just spits out an answer.
Yeah.
So how does it know those lengths?
So there's formulas built into the calculator that figure it out.
By one angle? It can
Yep, yep, yep. Cosine of 25, yep. It just plugs it into a formula and figures it out.
Oh.
The way we do it is we draw a picture and we figure it out, because we're not calculators.
Yeah.
Yeah. Yep. All right, let's try another one pretty similar to that. Let's try this one. Cotangent divided by cosecant. Okay. All right, so to do this one, the first thing I want to do is just kind of warm up with numbers. If you had, let's say, 2/3, and I wanted you to divide that by 4/5. How do you divide 2/3 by 4/5?
Don't you have to find like
Flip the 4/5 and then multiply them.
Okay, so multiply, and you said flip the 4/5.
so then that cancels the bottom.
Anything else?
Did you do the same thing to do 3?
You keep the 2/3 the same.
You keep the 2/3 the same. Yep. That's how you divide two fractions. Right? Keep the top the same,
And then flip the bottom.
and you multiply by the bottom flipped. So this would be 10 over 12, which then you could reduce. But the important thing is just to understand, you flip the one in the bottom and multiply. Okay. So now we're going to try that over here. Okay. Do we have, is the top a sine or a cosine as it is right now?
No.
Nope. Is the bottom a sine or a cosine?
No.
No. So we're going to change both of them into sines and cosines. What is cotangent? Look back, you can look back at your formula.
Cosine over
1 over 10, maybe?
Okay, it is 1 over tan, but remember the trick I gave you was to change it to
Cosine over sine.
cosine over sine. So let's start with that. Cosine over sine. And now the bottom, cosecant. Is cosecant a sine or a cosine the way it's written right there?
No.
No. What's cosecant?
1 over sine.
1 over sine. Okay. Now we've got exactly the same thing we had over there. We've got a fraction divided by another fraction. Okay. So how do I simplify that? Keep what?
The top one,
Keep the top one. All right. So
and then you multiply it by sine over 1.
and then multiply it by the bottom one flipped.
Yay.
Yep. Now, when we multiply, look for any trig function that you have in the top and the bottom that is the same.
I see 1.
Yep, what's the same?
Sine.
How many signs do you have in the bottom?
1.
And how many in the top?
1.
1. 1 in the bottom, 1 in the top. They cancel each other out. Just like having this. 1 in the top, 1 in the bottom. Once you cancel those out, what's left in the top?
Cosine over 1.
Cosine over 1. And what's cosine divided by 1?
I don't know.
Isn't it cosine?
Just cosine.
How do you know that?
Because anything
Because
divided by
anything
1
divided
is
by
itself.
the same.
Wait, so is it always going to simplify out to one or the other?
No, but it'll simplify down to something hopefully that's simpler than what you started with.
Are there ever going to be like numbers in this?
Yeah, the last problem was a number. The final answer was just the number 1.
No, I mean like, is it going to be like
In the work?
7? Yeah. So what?
Nope.
Won't ever be like 7 cosine, whatever.
No.
Okay.
Nope, this will always be a variable. It could be a theta, it could be an x, it could be a y.
There'll be no numbers before either.
No. Nope, generally no numbers.
Okay.
Maybe like rubber. Believe in yourself, guys.
Okay. So what we just did in this problem, if you take the cotangent of anything and divide by the cosecant,
It'll always be.
it's always just the cosine. So cosine is a much simpler way of doing this.
I see.
That's the point. So the next step now would be in calculus to do something with this because it's easier to work with than what we started with. We don't go any further than that. But it's a lot easier to work with something that's not a fraction than something that is a fraction. All right, any question on that one? We're gonna try, we'll try a few more. But that's basically the idea. All right, let's try this one. Cosecant times tangent. Okay, so you want to look at it. Do you have anything there that's already sine or cosine?
No.
Nope, then we're going to change both of them. If you have something that's already sine or cosine, you're going to leave it. Let's start with cosecant. So you go back to your page, look at your formulas, and find a formula for cosecant.
1/sine.
Yep. Over sine. And again, the letter they use right here, this doesn't matter. It could be an x. I'm just using theta. How about tangent?
Sine over cosine.
Sine over cosine. Okay, and we're multiplying. So anything that's the same in the top and the bottom?
No.
Yes, sine.
Sine.
Oh, we're doing
As long as you're multiplying, you can cancel the same thing that's in the top and the bottom. Okay, when you are adding, like if you had something like this, you definitely cannot cancel the 3's. When you're adding two fractions together, and even though you've got the same number in the top and the bottom, you don't just cancel the 3's and say, oh, it's 5 over 2. That doesn't work at all. Okay, but if this is multiplication between the two things, then yes, you can cancel the 3's. So you got to make sure you have multiplication. But we do. So the signs cancel. What's left in the top?
1 over cosine.
1 over cosine. And now 1 over cosine is one of our trig functions. Which one is cosine flipped?
Secant.
Secant. So if you need to take the cosecant of an angle, multiply it by the tangent of an angle, you could just do the secant. That's a simpler way of doing all of that.
Will the answer always be just one function?
Not always, no. No. But I'm starting out with one function for now. Yeah. Okay. Any question on that one? Let's see if I've got. Let's try, let me make up another one. Let's do example 2a. Let's do cosecant. This time I'm going to use a different letter. Cosecant of x times,
Does that change anything?
no. I want to make sure that that's going to work first. So that's fine. We'll just do that. All right. So cosecant of x times cotangent of x. Do you have anything there that's sine or cosine already? Nope. Then we're going to change both. Okay. What's cosecant?
Over sine.
1 over sine. And this time I'm using x instead of theta. That doesn't change anything. And what is cotangent?
1 over 2.
1 over tan.
It is 1 over tangent. What else is there?
Tangent x.
Cosine over what? Cosine over sine. Remember, the goal is to change everything to sines and cosines. Okay. Do we have anything that's the same in the top and the bottom?
No.
No. So if we multiply the top, what's 1 times cosine?
Cosine x.
Cosine x. And sine times sine is just like if you did y times y.
Sine squared.
That's sine
Sine.
squared. Yep. So in this case, did it simplify from what we started with? I would say no. It didn't really simplify this time.
So would that not be the answer?
That is the answer. It's just not really much simpler than what you started with.
So it's not simplified?
That's as much as you can do.
I see.
Usually they set these problems up so something cancels in the top and the bottom, but nothing canceled this time. So if they said to simplify, that's as much as you could do. I would probably write for this problem, change to sine and cosine. That would be the directions. And that's what you would get. So there is a number right there, but not, I don't think, the kind of numbers you were
No.
thinking of. Yeah. Okay. Any question on that one? Let's try another one. I don't think I want to do that one yet.
Mr. Hager, how's your day going?
Good. How about you?
Pretty good.
All right, let's try this one. So generally we change things to sines and cosines. This one already has sines and cosines. So what we might do in this one is try to change it back. Sine over cosine plus 1 over cotangent. I'm going to look at it as two separate problems. Start with just this.
So would the first one be tangent?
The first one is just a tangent. Plus, what's 1 over cotangent?
Tangent.
That's also a tangent. So you have tangent plus tangent. It's kind of like doing x plus x.
Where
What's-
did- oh, right.
What do you think tangent plus tangent is?
Two tangent.
2 tangent. And that would be it. That's as simple as you can write it. And I think this time that is a lot simpler than what you started with.
Yeah.
Okay, you started with two separate fractions. So if you had to do all of this in a problem, you could just do this, and it's a lot easier, and it's a lot shorter. Take the tangent and double it. So once, if you put these examples down on your reference sheet, I think once you see all the different kinds of things you can do, we're never going to do anything other than those. So once you see all the different patterns, then you always just follow one of those patterns to simplify the problem.
What if we just write down every single solution?
Well, then it's like if you tried to write down every single equation in algebra. There's infinitely many of them. So,
Or is there?
what?
Or is there?
There is, yeah.
I guess there's a limited amount of pencils and paper too.
Yeah.
I'll let that be one.
So you might take you a while.
Not me.
Let's try. Let's try this one. Okay, so this one's a little different, but they give you a hint,
Hey, excuse me.
and the hint that they give you is to multiply the top and the bottom by what's called the conjugate.
How do you know when to do that?
I would probably give you a hint that says to do that.
What a
Yeah.
guy.
Is that 1 minus cosine or the reciprocal?
So it's 1 minus cosine squared in the top
I get you are a smart cookie.
over 1 minus cosine in the bottom.
Do you have a stapler?
Yeah, do you need it right this second?
Try to fix his pencil.
Okay, do you need something else to write with?
That's all right.
Okay. So this is a problem where we're going to do this step. That's all we're going to do because I need to teach you something else with the top tomorrow. Okay, so all we're going to practice here is multiplying by the conjugate. The conjugate is when you take that sign and you change it to its opposite.
Change it to what?
Change it to its opposite.
Just
So-
the
Just the sign, yep, just the sign of what's in the bottom. So we have 1 minus cosine in the bottom. The conjugate is 1 plus cosine. So let's do that out. in the top, we're not going to do anything out. We're just going to write 1 plus cosine. In the bottom, we are going to do it out because I want to practice just foiling this out. There is something that would happen in the top, but we're going to learn tomorrow. So just leave the top and don't do anything to it. 1 minus cosine squared and 1 plus cosine. Okay, what I want to practice here is FOIL.
Wait, why are they both on the same thing now?
What's that?
How'd they get there?
So we multiplied the top and the bottom.
Oh, we're multiplying this?
Yep.
Wait,
So we're going to multiply the top and the bottom of your fraction by the conjugate of what's in the
I
bottom.
thought you were rewriting the problem.
So the bottom is 1 minus cosine. The conjugate is 1 plus cosine. So we're multiplying top and bottom by 1 plus cosine. Something happens in the top, which we're not going to talk about today. Okay. All I want to do in this problem is this. That times that, that times that, that times that, and that times that. So it's FOIL. What's 1 times 1?
1.
So that gives you 1. What's 1 times cosine? That's positive cosine. What's 1 times negative cosine? Negative cosine. What happens when you take a positive cosine and combine it with a negative cosine? They cancel. That's always going to happen with conjugates. And we'll do another conjugate in a minute. Okay, but those cancel. Now the last part. What's a negative times a positive?
Negative.
Negative. And what's cosine times cosine?
2 cosine.
That's cosine plus
Is it
cosine.
cosine squared?
Cosine times cosine is cosine squared. Oh, actually, I can do this problem. It's not going to be the hard version, I thought. Okay. What do you notice about what's in the top and what's in the bottom?
They both have cosine squared.
More than that.
The first one on the top and the bottom cancel?
Right. There's a 1 minus cosine squared in the top. There's a 1 minus cosine squared in the bottom. If you have the same thing in the top and the bottom of a fraction, it
Should be
cancels.
1 plus cosine.
And that's it. Yep. I thought it was going to be something more complex. That's it. So the original problem is what we had in black. If you had to do what I just circled, the original problem, a simpler way of doing that is to just do this instead, and it's exactly the same thing. So this is a simpler version of that. Okay. Any question on that one?
Hey, why at a weekend? It's nap time. Time for learning.
Okay. Let's just try multiplying by a conjugate. Let's call this 3b. Let's take 1 plus sine.
Wait, are we not simplifying anymore?
I just want to practice multiplying again. So this would be part of a simplified problem, but I just want to practice this one thing. Okay. What's the first thing you would multiply with these two?
1 and 1.
1 and 1, which gives you
1.
1. All right, what's the next part?
Sine and
1 and sine, negative sine.
1 and negative sine, which gives you
negative sine.
negative sine. But-
Sine times negative sine.
But then what's 1 times sine? Sine.
Cancel.
So yeah, negative sine, positive sine. That's what always happens when you multiply conjugates. Those disappear.
And then
What's a positive times a negative?
negative.
Negative. Sine times sine.
Sine squared.
Sine squared. So after you cancel that,
It'd be
1
1
minus
minus
sine
sine.
squared.
yep. And again, that one I just wanted to practice multiplying,
I see
just
now.
foiling it out. This is something special we'll talk about tomorrow. Any question on that? All right, let's try. Okay, let's try this one. And again, my hint on this one is to multiply by the conjugate. If you look at the bottom, what's the conjugate of the bottom?
1 minus sign.
Yep. It's just when you take this symbol and you make it the opposite. So it's a plus, make it a minus. And again, how would you know to do that? I would give you a hint saying multiply by the conjugate. Now, look at what's in the top. Okay, there's three different things in the top. 1, 2, 3. I'm not going to multiply any of that out. Just leave it. Because chances are when you multiply the 2 in the bottom, it's going to cancel something that's already in the top. So literally copy the entire top down and keep it the same. So the top has a secant. It has a 1 minus sign squared, which may or may not be there in a minute, and a 1 minus sign. Now the bottom we just did. The bottom is 1 plus sign times 1 minus sign. That's what we just did right there. That's why I did this one. What did we get when we multiplied 1 plus sign times 1 minus sign?
Minus sign squared.
Yeah, what did we get?
1 minus sign squared.
Yeah. So this part right here that I just circled, we just did that right up there.
Oh, and it's 1 minus sign.
It's
squared.
we already know it's 1 minus sign squared. Now, is there anything that the top and bottom have
1
that's the
minus
same?
sign squared.
Yep. So that's the same. That's the same. And now what's left in the top?
Secant times 1 minus sign.
Yep. And that's it. Secant times 1 minus sign. So you just cancel out what you can, and then you're done. Any question on that one?
Ms. Hager, are the other kids taking their final this week?
No.
Oh, I didn't know
Our
why.
finals are next Tuesday, academics break.
I didn't know why you kept that.
Which day do we have your class?
That's for the.
This week?
Yeah.
We have class Wednesday, Thursday, Friday.
Don't the
Wednesday, Thursday,
Wait,
Friday.
you don't have your class tomorrow?
No class tomorrow.
don't the freshmen have their bio MCAS 2 coming up?
But that's in
That, that's next academic week.
Is it really?
It's next academic week, I'm pretty sure. It's next academic Wednesday and Thursday.
And
Yeah, maybe. We'll take a look at that.
how's that gonna work with our,
Yes, we did.
Okay, let's try this one.
We did?
Isn't it secant?
So yeah, what did we say this one was earlier?
1 over sine. And
1
then
over
we have
sine.
sine over cosine. Should be 1 over cosine. Should
And
be
Wait,
tangent.
we're going too quick. What is going on?
We already did this.
We already did the problem.
And tangent was sine over cosine. And then what canceled?
Sign.
Yeah, the sines canceled out. And we were left with what?
1 over cosine. Which
1 over
equals-
cosine. Which was what? Secant. So let's try one similar to that, but a little different. Let's do cotangent times
Sin.
let's do you could do cotangent times, yeah, we could do sine. Okay. Do we have anything there that's already sine or cosine?
Yes, we do.
Yeah, which one?
Sine.
Sine. Just leave that one then.
Cotangent would be,
What's cotangent?
sine over.
Cosine over sine.
Cosine over sine.
I'm trying to remember if that was in
Now, once you make cotangent into a fraction, I would make this into a fraction as well. How can you make something a fraction?
Put a 1.
You can always just put a
So
1.
wouldn't the sign cancel out?
Yeah.
So then it'd be
Yeah.
Oh,
cosine.
do you have a computer card?
So
Huh?
what's the same in the top and the bottom?
The sign.
The sign. And what are you left with?
Cosine.
Cosine.
Yeah, what do I
Okay,
get?
so that's another trig identity where it's simplified down to just one function when you're done.
I see.
So this times this is the same as just doing this, which is a lot simpler. Any question on that one? Let's try, I'm not doing that one. Let's try this one. Okay, what property do you think comes up in this one? And it would be very similar to the property that comes up right there. Distributive, yep. So anything you can do with numbers, we can do the same thing with this. You need to distribute out what you have in front. Well, here you're distributing 3. What are you distributing there?
What is sine?
Sine. So that's the first thing you're going to write down. Literally, it's sine times cotangent. Sine times cotangent. And then we're going to come back and see if we can simplify that. Plus, what else are you going to multiply sine by?
Tangent.
Tangent. Sine times
Now,
tangent.
should we put these in parentheses?
Once you use the distributive property, you don't need to.
Okay.
Yep. Just like you could just write this. If you write this, that's okay.
Okay.
You don't
Yes, you know.
need to do that. All right. Do we have any sines or cosines right there?
Yes.
Okay. So leave that one then. What's not sine or cosine?
Cotangent.
This. We need to fix that. How can we change cotangent?
Cosine over sine.
We can make it cosine over sine. And I like to make that other one a fraction, so
And then the signs cancel out.
what can we put in the bottom?
1.
A 1. Yeah, and the signs are going to cancel. We'll come back to that. Is there anything over here that's not sine or cosine?
Tangent.
Tangent. Then I don't want that one there.
Let's get rid of it.
How can we change it?
1 over cosine.
We can make it sine over cosine. And what can I put in the bottom of this?
1.
Oh, just a 1. Okay. Is there anything in the same for the top and the bottom here?
No.
No.
Okay. Can I cancel this cosine with that cosine?
Yes.
Yep.
No.
Are you sure?
Oh, no, because you
No.
have to do
Why not?
times first.
Because you have to, yeah.
What symbol is there that's, I told you you
Well,
can't do that?
multiplication.
Addition.
You have a
Addition.
plus sign, like if you have this, you cannot cancel the 3's.
No.
That doesn't work. If it's multiplication, just a dot in the middle, then yes, you can cancel. So nothing else cancels. What's left right here?
Cosine.
Cosine. And here, multiply straight across.
So sine squared.
Sine squared
Over cosine.
over cosine.
I love that we're not doing numbers.
Now, there's one more thing I'm going to show you. We're not going to be able to finish this today because I didn't teach you the other thing you need to finish it. But if I want to add 2 fractions together, what do you need to have?
Common
You need a common denominator.
Common denominator.
So let's say we had 5 over 2 plus,
Multiply the bottom and the top.
let's say 3 over,
5.
yeah, we could do, well, I don't want to do 5. Let's do another number. Let's do like 4. How do you find a
You
common
multiply the
denominator?
first one by 2. The top and the bottom by 2. So
Okay.
that the bottoms are the same.
Yeah, you just have to find a number that you can multiply
So we
top and
multiply
bottom by.
cosine. So wait, couldn't we just easily do that and make it cosine squared and then cosine bottom?
Well, let's make sure we get this, and then yeah, we'll do that. So here, you have 10 fourths plus 3 fourths, which is 13 fourths. Right? You can do that because you found a common denominator.
Yes.
Now we're going to do the same thing over here. The common denominator is generally, well, you could have done 8 here if you wanted.
Don't know what.
You could have done 8
Yes.
as a common denominator by just multiplying these two together. It's not the smallest one, but it would have worked. The way we're always going to do it is multiply the two together. If you multiply this and this together, what do you get? Cosine. This denominator is already cosine. What would you have to multiply this by to make this a cosine?
Cosine.
But if you do it in the bottom, where else do you have to do it?
The top. Isn't
The
it
top.
just cosine squared, right?
Just like you had right there. Yep.
Cosine squared plus
So what's cosine times cosine? Cosine squared. And what else is in the top? Sine squared. And what's your common denominator? Cosine. Now, sine squared plus cosine squared is something special. But we're going to look at that tomorrow.
Wait, why is it all one fraction? What? Because they just combine.
So in this one, it's like if I did 10 plus 3 all in one fraction now, because I have a common denominator.
Okay, wait. Do that. Okay.
I actually don't mind this.
Let's do another one where you just find a common denominator. Let's do sine over 1 plus, let's do cosine squared over sine. The directions are add. Okay. What do you need when you're going to add two fractions? What do you have to make sure you have?
Common
Common
denominator.
denominator.
Common denominator. What's going to be our common denominator here? Sine. The common denominator is always going to be these two multiplied together. Do we already have sine in one of them?
Yeah.
So we don't need to change that one. Which fraction is missing sine? The first one. What would you multiply the bottom by
Sine.
to turn it into the one on the right?
Sine.
Sine.
Then would you try to do the top by sine too?
And then you have to also do it in the top.
So wouldn't it be like sine squared over sine?
Yeah, we just did it.
Sine squared
Plus cosine squared over sine.
plus cosine squared
Below my chest. Over sine.
over sine. And again, sine squared plus cosine squared is something special. Okay, but I'll show you what that is tomorrow. This actually turns into a very nice thing.
Why is it
I don't
special?
think so.
Turns into what?
Why is it special?
Because this part that I just circled is
Yeah.
going to turn into the number 1.
Oh.
Does it
I
cancel
like
out?
that.
Yeah, it all is going to disappear and it's just going to become 1. But we'll look at that tomorrow. So any question on the common denominator?
What if it's subtraction?
What if the
No.
You
bottom
can use
number?
It would do-
subtraction, you
yeah.
still have to do common denominators, yes.
What if the bottom number isn't 1?
You would still just tax it?
So if you don't have a 1, let's say you had
What if it's like a 3?
Yeah, you 3 times the sine.
like you want to do a 3?
Well, I just don't know how it would be if it was a different number. Or like something that wasn't a 1.
In our problems, it's usually going to be a 1 or a trig function.
How would you do it if it's a trig function?
Like if you had something like this,
Yeah, and the common denominator just needed to be like a sine or something. Like how would you
Okay.
like do that?
so let's add these together.
Well, maybe not.
Cosine.
Yeah,
So what's going to be our common denominator?
I don't know. It could be either.
When we do multiply them both,
You multiply them both together, so the common denominator is going to
Sine
be
squared.
cosine the sine.
cosine sine.
Yeah.
So your common, like if, let me do it with numbers. The common denominator is always going to be the product of these two. So like in this case, it's going to be something with a 28. Common denominator,
No, not this one.
common denominator here is going to be a cosine times sine. Okay.
So when you do multiply them
So what is the fraction on the left missing?
Sine.
It's missing the sign. Just like over here, this fraction's missing the 4.
So wouldn't it be 1 over cosine and sine? Because when you multiply by...
Oh, it'd be squared.
So what are we going to multiply by here?
Sine.
Sine
Oh, the sine.
Is the other one taking cosine?
over what?
Cosine.
No,
Cosine.
sine.
No, sine.
Sine. So that's just like this. You multiply this fraction by that denominator, and then you multiply this fraction by that denominator.
So it'd be sine squared plus cosine squared.
Plus times, what are we going to put here?
Cosine.
Cosine over
Cosine.
Cosine.
cosine. So in the bottom, you've got sine times cosine for both of them. That's cosine times sine, same thing. And what's sine times sine?
Sine squared.
Sine squared. And cosine times cosine.
Cosine.
Cosine squared.
Cosine squared. And again, cosine plus cosine squared is something special. But that's tomorrow.
I see.
So that's how you do it with that one.
Thank you.
Yep. Let's try.
Is this all we're doing today?
Yes. Okay, so let's look at this one. So this one is like the simplify ones we were doing. The difference is they tell you what the final answer is going to be, right? So they give you something on the left that you need to simplify. They give you what the final answer is going to be. What you have to do is show how to change this into that. So,
Why would you give you the final answer? I don't understand.
so this kind of problem is called establish, or you might see the word
Verify.
verify. So verify is easier than simplify. Because with verify, you know what to start with, you know what you're going to end with, you just have to figure out the steps in the
Can we
middle.
do this one?
That's
Yeah.
what we're doing.
So for now, forget about the answer. We're just going to check it when we're done. So we've got secant times cotangent. And we've got to simplify that as much as we can. Do we have any sines or cosines? No. What is secant?
Secant is, I remember, 1 over cosine.
1 over 1 over cosine. What's cotangent?
One over tangent. No.
So you can do it as
Cosine
1 over
sine.
tangent.
Over sine.
We're going to try to do it as sines and cosines.
Cosine over sine.
Cosine over sine. And now you're multiplying, so if there is anything in the top and the bottom the same, it does cancel.
Cancel, yeah. The cosine.
Cosine.
The cosine cancels,
So it'd be left.
and what are you left with?
1 over sine.
And
But
what,
doesn't that equal sine? Or no?
what trig function do you get if you flip the sign?
Cosecant.
You get the cosecant, which is exactly what they said you should get.
I see now. Thank you.
So that's, you're welcome. So that's a verify. They tell you the answer, you just show the steps, and if you don't get that, you did something wrong. Okay. Any question on that one? Yep.
Will they ever say, see if this is true or not?
No, if it's a verify, it's always going to be true. You just have to show the steps. Yep.
Is it fair? Is it not?
All right. So let's look at number 8. So when you're doing an identity like this, always start with the side that looks more complicated. So like this is the side you want to try to simplify. Right? In this problem, that's what's more complicated. In this problem, I would say that's more complicated.
Okay, and this is just verifying, right?
Yep.
Okay.
And
So how do you make cosine a fraction?
Put it under 1.
Put a 1. Now for now, forget about the cotangent. That's
That's the answer.
that's the answer. We're going to see what we get. So multiply straight across. What's cosine times 1? Cosine. And what's 1 times sine?
Sine.
And that
Sine.
equals cotangent.
And that is cotangent because one of the formulas I wrote down on the paper.
Okay.
And that's the same as that. And which other one?
4.
Four?
But can you also do 9?
So which property do you think we need to use in this one?
Distributed?
Yes. So we need to distribute. What are you distributing?
The sign.
Sine times, the first one is what?
A lot?
No.
Sine times cotangent.
Sine times cotangent. Copy down your plus sign.
Wait, do you have minus?
Nope, that's a times.
Oh, okay,
What do we multiply sine by next?
sorry. Cosecant times tangent.
What's this one?
Cosine?
Sine times cosine times tangent.
Yes.
So the hope is something's going to cancel there. So we have sine times cosine times tangent. So that's when you multiply sine to both of them. All right. Now write everything as sines and cosines with fractions, and we'll get some things that cancel. How can you write sine as a fraction?
Sine over 1.
How about cotangent?
1 over tangent, or
You can do 1 over
cosine
tangent.
over sine.
Unfortunately, that one won't help us.
Cosine over sine.
Cosine over sine. We'll come back to that. How about if we write sine as a fraction?
Sine
1 over sine.
1 over sine.
Sine over 1. How about cosine as a fraction?
Cosine over sine.
Cosine over
Cosine over 1.
Yeah, we're just putting it over 1 to make it a fraction. And what about tangent?
Sine over cosine.
Sine over cosine. Okay. Now, where you see a plus sign, that separates it into two problems.
Can you?
Don't try to mix the two together.
You can cancel
The
the both
cosine
sides.
cancel.
You can cancel the signs.
So it'd be cosine.
So on the left, you have just a cosine plus
Sine squared.
what happens on the right.
The
This-
cosines
cosines
cancel out,
cancel,
so
and then
you
you
times
multiply.
the other two.
And what do you get when you do sine times sine? Sine squared. And what were we supposed to get?
That.
That. So we got it.
So the fact that it's under 1 doesn't matter, or over 1 doesn't matter.
No, I just made it a fraction because everything else was fractions.
Okay, I get it.
That's why you put it on the graph.
All right, so that's the idea of the problems in the homework.
Can you print it out?
Yep, I can print it out. I'll let you try number 9.
Number 9's easy.
That one might end up as a fraction divided by a fraction, maybe. Yeah, there's different ways you can do it. But you know the answer, so you just have to figure out how to get there. But yeah, I can print that out.
So it's printed, so you don't have to write any problems down.
Okay, so the homework tonight is going to be the worksheet.
I let you do worksheets.
Can you print out the worksheet? Yeah.
Yes.
He already said he would.